Okay, can somebody please unmute themselves? Can you hear me plenty loud over the music, or do I need to turn the music down even more? Anyone? We're fine? Okay, cool. All right, I'm going to just do one column at a time. So we're going to start with the earth science stuff. Here we go. Oh, and the way that this is going to work is once you know the answer or you think you know the answer, just put your hand up. And when a good number of students have had an opportunity to locate the answer or demonstrate that they know it or they think they know it, then I'll show what the answer is. Okay, so that's the little blue hand that you're putting up. All right, here we go.
The music is kind of loud.
Okay, let me turn it down a little bit more. Come on now. Really? Oh, yeah. Okay, there we go. Okay, here we go. Better? All right, here we go. Okay, what is the reason why a desert would be found in the tropics? What? Resume share. Hold on a second. Resume share. Okay. What is going on? Hold on a minute. Ay. Give me a second. I got to do this again. What it is. Bam. Houston, we have a problem. Okay, we should be working now. Boom. Boom. Okay. There we go. What is the reason why a desert would be found in the tropics where we would expect to find environments with rainfall? There are a couple reasons why you would have little to no rainfall at the equator. See if you can come up with at least one or two of those. And again, when you're pretty sure you know what the answer is, raise your hand. You don't have to know what the answer is. Hold on, Spencer. What was that, Spencer? Yeah. Better? Okay, cool. And all right. Okay, so again, put your hand up when you know at least one of the reasons why you would have little to no rainfall where you would normally expect to find rainfall at the tropics or near the equator. And once I get a good number of kids that have a hand up, I'll show you guys the answer. Also, I'll pull the microphone right in front of me. That should help out a little bit too. All right, I got one person that knows what the answer is. I know there are more of you guys out there. Come on. One is a phenomenon that actually happens up near Auburn and Newcastle and Weimar and Colfax. You'll notice it's really, really green. And then all of a sudden you hit Truckee and you start going down the other side. It's all desert. So if you know what that phenomenon is called. Okay, about 15 seconds for you to try to find this. This would be in your Intro to Earth Science class notes. And if you have not, if all of your stuff is in the classroom and you don't actually have that on your device, maybe what you should be doing over the weekend is just making sure that you save all those documents in your drive or to your device so you have easy access. I wouldn't necessarily go so far as printing everything, but if you like to have the stuff in front of you to guarantee that you're going to have it. All right, here we go. Got two people with a hand up. That's not good enough for me, but time to move on. Okay, there are really three reasons. One is called the rain shadow effect. Remember, as air is being blown, it's being blown from the west in our case. It gets blown up over the Sierra Nevada. It gets colder as it rises into the atmosphere. The molecules lose their energy, and the molecules get closer together and they condense. And they get so close together that they form raindrops, and then they form larger raindrops, and then there's the opportunity for them to fall out of the sky. That's what happens in the Sahara. There is actually a mountain range in between the Atlantic Ocean and the Sahara Desert. So that's one reason. Also, cold water. If there's a cold ocean current near, remember, that is going to cool the air down, and colder air is much less likely to contain water vapor than is warmer air. So it could be a cold ocean current. Or it could be descending dry air. It could be a high pressure system. And the Sahara Desert, which is at the equator, is actually dominated by high pressure. Remember, high pressure is the atmosphere is pushing down on the surface, making it harder for air with water vapor to rise. Condensation can't take place. Cloud formation can't take place. And of course, if you don't have any cloud formation, you don't have any precipitation. So those are the three primary reasons why you would have a dry area near the tropics. Okay. All right, here we go. Next one. Which layer of the atmosphere does most global warming take place within? What's the cause of wind currents curving either clockwise or counterclockwise in the north or south hemispheres? And I'll give you a clue. What layer of the atmosphere are most greenhouse gases found in for that first one? And as soon as you know both of the answers, or you think you know both of the answers, put your hand up, please. I'll give you a clue. What layer of the atmosphere has most of the pollution? Greenhouse gases are considered pollution. And then the second one was named after a French guy. Oh, oui, oui. We're going to go. Nope, we're not. Let's go 50 minutes. Sorry, I'm talking to myself. I'm setting a timer. All right, about 15 more seconds. I know more than 3 of you know the answer to this. Come on, what layer of the atmosphere has most of the pollution? All of the clouds, because remember, water vapor is a greenhouse gas. What's the name of that phenomenon that causes hurricanes to have a certain spin direction in the northern hemisphere and a different one in the southern hemisphere? That's the participation I'm looking for. Okay, good. All right, correct answer is the troposphere. That's where we live. The troposphere has most of the pollution, most of the mass of the atmosphere. It's got all the clouds. Clouds are actually a greenhouse gas. It's got all the carbon dioxide, all the methane that we're putting in there. And then, of course, the effect named after Henri Coriolis, the Coriolis effect, causes it to bend one way in the north and one way in the south. All right, sorry, not doing the 80s metal today. Let's see, I'm going to fast forward. Yeah, again. Okay, here we go, next one. Okay, what's the cause of wind and ocean currents moving heat around the Earth due to variations in heating of oceans and land? What's it called when cold and oxygen and nutrient-rich waters are brought to the surface from deeper ocean levels? Which ocean current brings warm water to North America and Europe, moderating land temperatures? Yeah, okay, that should sound very familiar, kids. So there are 3 questions up there. If you think you know the answer to 2 of them, at least 2 of them, put your hand up. Everybody knows the answer to 1 of them. And I'm seeing a lot of the same people put their hands up, which means you've done some preparation already, or you have a photographic memory like my brother, and I hate him for that. It takes me 5, 6, 7 times to memorize things, and he'll remember conversations from 10 years ago. Heard it once. Okay. The phenomenon for the second question happens off of the coast of California, and that is one of the reasons why we have so much diversity. It's also one of the reasons why we have so many sharks. It's because there are so many things living off the coast of California. And there is a 2-word term for the first question that describes areas of the Earth getting more sunlight, solar radiation than other areas of the Earth. I've seen lots of hands. I like it. I like it. I like it. 10 more seconds to try to find these answers. By the way, if you don't know what the answers are, I would at least try to locate these questions on your study guide, because these will answer some of the questions on your study guide. So you can actually kind of turn this into a work day if your study guide is very incomplete. All right, here we go. Answers are, it's called differential heating. Differential heating describes the fact that the equator or the tropics get more solar radiation than do the poles, and then wind and ocean currents need to move that excess or inequity of heat towards the poles. Okay. Upwelling currents are what bring cold, nutrient-rich, oxygen-rich water from the depths. And of course, that feeds food chains and food webs. And of course, the last one is the North Atlantic or the Gulf Stream current. All right, here we go. Chapter 1 stuff. Let's see. What does this say? Creating and using renewable sources of construction material is an example of blank development. Oh, come on. Lots of hands should be jumping straight up. You've seen this like recently. All right, good. Okay, you guys can remember 20 minutes ago. All right, that is an example of sustainable development. Nicely done. So again, you're going to want to have your warm-ups out. I pull some of the warm-up questions onto the test. All right, here we go. 2-point question. List 3 reasons for starvation and famine. There are lots of them, but see if you can come up with 3. Let's see. The following are benefits of blank. These residents tend to live longer and have lower infant mortality rates. Recycling is more economically feasible because recyclables are concentrated. These residents have better access to medicine and education. So what word makes that statement true? And see if you can come up with reasons for starvation or famine. And if you think you know the answer to 2 questions, to both of them, throw your hand up. And if you're putting your hand up a lot and getting a lot of these questions correct, you're going to kill this test. I mean, you still got Thursday night, Friday night, Saturday night, and Sunday night to prepare. And it's open book, and it's open note. And the second part of this slide, the second question on this slide is kind of near and dear to me. I've kind of lived 2 different lives, and I think I'm going back to the other one once I get ready to retire. All right, here we go. I'm going to turn this down a little bit. Sorry, Snap. Okay, here we go. Okay, drought, population increase, climate change, deforestation, salinization, which is the turning of soil from fertile soil to soil that has a lot of salt, basically overusing land. All of those are reasons for starvation or famine. And then urbanization. So I grew up in a town. It's called Quincy. It's up in Plumas County. It's about 2 hours and 45 minutes away from here. 5,000 people. There were only 600 people in my high school, and that was grades 7 through 12. My graduating class was 88 people. So a real small community, right? Of course, I hated it when I was a teenager because really the only thing we could do is like ride our bikes to the river and go swimming, or once I was able to drive my car to the river and go swimming. And of course, I got to Sacramento, and it's all bright lights and all these things to do, and and I like the conveniences of we've got first responders, plenty of them. So we've got hospitals, lots of hospitals. So if you get hurt, you can get treatment right away. So there are lots of benefits of being in the city, but it's loud and it's dirty and there's a lot more crime and they're hotter because there's so much concrete. So I don't know. I'm thinking when I'm about halfway through my career, I think I'm going to go 30 years. I'm at year 16. So I think when I'm ready to retire, I'm thinking of buying a place near the beach because my wife really likes the beach. And then buying a place in the mountains, maybe Colorado or Montana or something, and smaller community. But there are certainly some nice things about some conveniences that we take for granted by living in the city. Okay. And some of you guys, by the time, you're finished, with high school, you might, I'm tired of this city business. I want to go to a junior college in a town, a small town or something. Who knows? All right, here we go. Last question for chapter 1. True or false? A non-utilitarian values forests because they provide lots of fuel wood. True or false? Reduced human population has had an effect on the environment. A blank society would emphasize using energy efficiently and reusing and recycling matter. So we got 3 questions up there. If you think you know the answer to at least 2 of them, put your hand up. Be real careful with the wording on the true-false questions. All right, we got some people figuring out a couple of them, or at least thinking that they have figured out a couple of them. Sorry, Stephen. There we go. A little Toto. Okay, 10 seconds, and I will reveal the answers. 5, 4, 3, 2, 1. All right, here we go. Okay, so a non-utilitarian a utilitarian values forest because they provide lots of fuel wood. The way that I remember what a utilitarian is they want to utilize resources. They have the belief that those resources are there for them to use and not necessarily there for other animals to use. So the non made the first one false. Okay. Reduced human population, has that an effect on the environment? No. An increase in the human population has had an impact on the environment. And whenever you have, you're thinking about all the things that are going wrong with the environment, I think about it a lot. Probably about 90% of the things that are going wrong with the environment, you can link to a expanding human population. And that's kind of a depressing thought because, we can't just decide to kill 1 billion people because there are too many people on the planet. We have to learn how to use what's left responsibly with a larger population. We can decrease the rate at which the population is increasing, but we can't make it a negative. Unless we have disease and diseases and famine are becoming more common, but human population, that is the primary reason for our situation. Let's see, last one. A sustainable society emphasizes using energy efficiently and reusing and recycling matter. Raise your hand if you have something in the place that you live that is energy efficient. Maybe you just got a brand new furnace for heating in the winter that's energy efficient, or maybe you've got the low E2 efficient windows. They keep the heat in, they keep the cold out. Or maybe you just got a brand new air conditioning unit that's energy efficient, or you got solar panels on your roof. These are expensive purchases. I've got solar panels. I actually leased them, so I didn't have to buy them. It would have been $20,000 if I would have bought them, but they kind of make you feel good about saving a little bit of energy. Maybe watering less. I've got neighbors that water twice a day, 7 days a week. I water once a day, 4 days a week. And probably in about a month, when it starts getting a little bit cooler, I'm going to quit watering for the entire winter, and I could care less if my lawn dies. I mean, hopefully it rains enough to keep it alive, but I really don't care because, I only like it to look nice and green when I'm outside a lot, and that's during the warm months. So there are lots of things you can do around the house to help out, and it makes you feel good when you do those things. Maybe it makes you feel bad if you're not doing any of those things. Anyway, moving on. Okay, chapter 2. Oh, let's see. I can't read this. A group with the same conditions as the experimental group, except for the study variable, is what? So if you've got 2 experiments going on, one of the experiments you are not changing a thing, and the other one you are manipulating a variable, what is that group called that you are making a comparison to? You guys should know this one. Not changing something in an experiment should give you a keyword. It should pop right into your head. Okay, maybe not. Okay, I'm not going to waste too much time on this one. That is referred to as the control group. A controlled experiment is where you lock everything down except for a single variable, so the dependent or responding variable can be directly linked to the manipulated or independent variable. All right, here we go. The greatest advantage of the blank blank is that it removes bias from observations of natural phenomena. A scientist used 2 types of food to see which one attracted insects more. After looking at the data, it was concluded that insects preferred one food type much more than the other. Which type of reasoning was used? Remember, there was inductive and deductive reasoning. My wife loves this band. I was a metalhead when I was a teenager. I thought these guys were soft. I like them now. Okay, so we got 2 questions up there. If you think you know the answers to both, or you know the answer to one and you think you know what the answer is to the other one. And I know the second one's kind of difficult because is the premise true? Is the premise not true? It's kind of funky examples. I know. First one should be pretty easy. I'll give you a clue for the first one. It's a process that people, not just scientists, that people use to find answers to questions. A series of 6 steps. 7th step could, be one of 2 things. It's a process that scientists use. All right, 20 seconds. I got a couple people with hands up. Anybody else? Think they know? All All right, cool. Getting some participation. Some people are feeling confident. I like it. I like it. I like it. All right, here we go. Answers are, that's a scientific method. And inductive reasoning. This is an example of inductive reasoning. And I get confused on inductive, deductive. The best advice that I can give you is go out and watch a YouTube video on differences between inductive and deductive reasoning, and hopefully they have a couple different examples, and you can look at the definitions and go, oh, okay, now I get it. Or, yeah, I don't get it. I got a 50-50 shot. That's, I guess, the best we can do. Okay? Yeah, it is what it is. It is what it is. All right, here we go. Next one, last one for chapter 2. Blank is often misrepresented by the media as verifiable and legitimate science. Oh, speaking of merchants of doubt, I mean that meanie, that bully, Mark Morano, who laughed at death threats and wanted to email him. My goodness, that guy is horrible. He claims to know atmospheric science because he took a class in college, and he's arguing with professional scientists that have devoted their life to making the world a better place. Anyway, it's that science that those guys that claim they know what they're talking about are talking about. What type of data is descriptive, has no numbers and no units? Remember, there are two types of data. There's quantitative and qualitative data. Which one is that? A generalization that arises from a set of observations. That is the definition of what? If you know or think you know 2 out of the 3 questions, hand up, please. All right, we are nearing 50%. Good. You guys are feeling good about this question or these questions. Right on. Okay, about 5 more seconds. Cool. And I'll be honest with you guys. I mean, I know that some of you are going to be FaceTiming and doing the test together. I know that's going to happen, but why let somebody else influence what you think the answer is? I like to overly prepare my kids. And if you're overly prepared, do it on your own. If you're overly prepared, if you got your study guide, you got all your notes, you've done all the notes, they're organized, why the heck would you need anybody's help? Why let them influence what you think the right answer is? Plus, you're really not going to have enough time to do that, especially if the person is holding you back. Okay? So please do your own work. All right, here we go. Next one. Answer, pseudoscience. Pseudo is false, okay, or fake science. Qualitative data. The easiest way to remember quantitative data is counted data. Quant, count. It's got numbers, it's got units, it's specific. And an inference is a generalization that arrives from a set of observations. We're going to skip chapter 3. We're going to save that for the end because you guys are probably least familiar with the chapter 3 stuff. All right, random stuff. Which of the following would have the least impact on mixing of ocean water in an estuary or a bay? This is a tough question. Surface currents, higher or stronger tides, snowmelt running into the bay, Coriolytic, which is the Coriolis effect, Coriolytic deflection of water out of the bay, or summer stratification or layering of the bay. What stratification means is distinct layers with depth in the bay. Okay, this is a tough one. So if you think you know what it is, remember, on the ones where you don't know what the answer is, try to eliminate some of the choices. That's just good multiple choice test taking technique. If you know that surface currents will definitely encourage mixing, it's not that answer. If you know that snowmelt running into the bay will definitely encourage mixing, it's not the answer. Try to eliminate choices that you know the answer is not, and it will increase your probability of guessing the correct one. And of course, you have the benefit of seeing a question similar, if not identical to this on the study guide, and seeing a question similar, if not identical to what you will see on the test in the Jeopardy. All right, about 15 seconds. Hand up if you think you know what the answer is. It's a tough question. I'll definitely admit that. And once I give you the logical explanation as to what the correct answer is, you'll go, oh, yeah, of course. You're not going to have any mixing if you have that. Duh. But it takes a little bit to get there. All right, here we go. 5, 4, 3, 2, 1. All right, here we go. Correct answer is stratification or layering. Leave your hand up if that's what you thought the answer was, or put your hand up if you thought that's what the answer was. And the reason why this kind of makes sense is if you actually have distinct layers within the bay, you don't have mixing. When you have mixing, all those layers are getting mixed together and there's no distinct definition of the surface layer, or if we're talking ocean, the thermocline and the bottom layer. If you have stratification, you do not have mixing, okay, in the bay, okay? And summertime would be most likely when that's going to occur because you're going to have less river runoff. You're going to have less rainfall, depending on where you are on the globe. So there will be less inflow into the bay. And the little inflow you do have would just simply be moving into that surface layer and not rushing in so fast that it has the potential of digging down into lower layers. Okay, hopefully my logical explanation is sitting with you, right? All right, next one. During what phenomenon will you have higher than normal ocean water and warmer than normal ocean temperatures near Peru and Ecuador? What's that phenomenon called? Remember Chris Farley? Yeah. Okay. Blank conservationists believe in protecting resources for their economic value, use, or profit. And I have a real hard time calling these people conservationists because they're not really conserving if they're taking, but you know. My first concert ever, Night Ranger, the Big Life Tour, Reno, Nevada. All right, see lots of hands. First one should be easy. Second one, maybe not so much. We did talk about the second one earlier. What are those people called that think that things on the planet exist for them to take and for them to use? Many mining companies have this belief. Many oil companies have this belief. Many timber companies or lumber companies have this belief. All right, here we go. 5, 4, 3, 2, 1. Okay, it's the El Nino Southern Oscillation, or ENSO. All you really need to remember is El Nino. And remember, utilitarians, I have a hard time calling them conservationists, but that kind of implies, it's kind of a, wait for it, it's kind of a pseudonym. But utilitarians, they believe that the resources that exist on this planet exist for us to use, exist for us to gain profits off of. And I don't really think that that's the definition of a conservationist. When I think of a conservationist, I think of people that say, oh, no. You go get your gold somewhere else because there are species that really need the land to stay intact here. So go get your gold somewhere else. Sorry. All right, here we go. Next one. Okay, 4 questions for you. Hand up if you think you know the answer to at least 3 of them. As air masses rise, they may result in rain. This fact is true because as the air mass cools, it is capable of holding blank moisture. Choices are less or more moisture. Which wind currents are found between the equator and 30 degrees north and south? They have rising air leading to cloud formation and surface winds blowing towards the equator. Which seismic wave is the fastest and least destructive? I'll give you a clue. It's the one that gets there. Wait for it. First. A set of components or parts that function together to act as a whole body is what? Oh man, I used to cruise my mom's station wagon up and down Main Street listening to this album, 5150 Van Halen. Yes, I did say cruising my mom's station wagon. You use what you got until you can get your own car. Sorry. It had mag rims on it. Come on. It was a cool little station wagon. It wasn't the big old honking ones you're thinking of. It was a Datsun. All right. If you think you know at least 3 of the answers of this 4, hand up. All right. I'm seeing a lot of the same hands. You guys should be feeling pretty good about this, knowing that the test is still 4 days away. And yes, we will be using the exact same type of preparation process to get ready for all the tests. The final for the end of this semester is going to be a little bit more difficult because there are going to be a lot of questions on it. So you can't have a Jeopardy that's going to take 3 hours to do. The Jeopardy questions will be the ones that are harder questions. I will take for granted that you are going to remember some of the things from the other units. So, as air masses rise and you result in rain, is colder air able to hold more or less moisture? Okay. What are the wind zones near the equator called? I'll give you a clue. They are the wind zones that slow, stop, or reverse for El Nino events. There are 3 types of earthquake waves. There are surface waves, there are secondary waves, and there are primary waves. Which ones are fastest and the least destructive? And the last one, that's a chapter 3 term. You may or may not know that. Again, if you think you know 3 out of the 4 or all 4, hand up. About 30 more seconds. If you don't know the answers, you should be finding these questions on your study guide, or you should be finding this information in your notes. First question, earthquake question. Those are earth science notes. Second question is earth science notes. Last one is chapter 3. All right, 10 seconds. It's real easy to figure out when your college student who is living with you and doing college virtually is not in class because he's screaming at the Xbox. He gets crazy into those games. Sorry. If you know Logan, tell him to keep it down when Dad's Zooming with his classes. All right, here we go, kids. First answer. Cold air has less energy. Also, as molecules slow down in their vibration, they get closer together. They condense. So there's less ability for cold air to hold water vapor. Remember, trade winds are easterly wind currents near the equator. The trade winds are the ones that slow, stop, or reverse to create El Nino events. Primary. The easiest way to remember primary is they get there first. And who gets there first? The fastest person gets there first. Many times, unless you're really, really close to the epicenter, you won't even feel the primary waves because they're compressional. They're push-pull waves. There's no vertical component to them. There's no rolling land. And if you do feel them, usually they feel kind of like a shock. And if you're driving, you'll never feel them because there's too much motion going on in a car. And set of components or parts that function together to act as a whole body is what that is referred to as a system. All right. And primarily you need to know about open and closed systems. I did put some diagrams out on the Google Classroom. You're going to need to do some memorization of those, or you could just be lazy and print them or have access to them during the test. Speaking about the test, I almost forgot to tell you guys this. I'm going to encourage you to stay in the Zoom, okay, when you are testing. Okay, so you can just minimize the window. Obviously, you're going to be muted and have your video mute and your audio mute. And that's way, if you have a question about the test, all you have to do is raise your hand, because I'll keep my participant window open. And then what I'll do is I'll invite you into a breakout room. And then you can ask your question. If it's a question that the entire class should have the benefit of, like if I made a typo or there's a mistake, I will share that with the entire class. But that's just like being in a room with testing blinders up and having the access to raise your hand so the teacher can come over and clarify. I did not do that last year, and the students said it would have been really nice to be able to ask you a question during the test. And we can do that because you can be live on Zoom, but to simply have the test open that way. And obviously, nobody should be talking during the tests. You'll raise your hand and you won't say, Paulus, I need to ask you a question. So that's something that I really would encourage you to do. I'm not going to make you do it. If you want to leave the room, that's fine, or leave the Zoom and go take the test. But it'll give you easy access for clarification. Okay. All right, here we go. Remember, you get calculators on the AP test this year, so don't worry about the long division. If you do not know the order of the prefixes for the metric system, you probably should write those down. So pull out a piece of paper. I call it the grid. And if you know how to move in the grid, you know how to convert in the metric system. Far left prefix is kilo, and it is the largest. Next one to the right is hecto, Hecto. Next one to the right is deca, Deca. Next one to the right in the middle, is the base unit. Base unit is going to be meter, liter, or gram. Next one to the right is deci, Deci. Notice we are getting smaller as we move from the left to the right. Next one to the right is centi. Last one on the right is milli. And milli is the smallest prefix you will need to know. So if you've got a metric system conversion, all you need to know is which direction you are moving in, again, what you just wrote down. I call it the grid. And how many spaces you move in the grid. And then all you got to do is move the decimal. So again, don't worry about the long division questions. Let's just do the metric system conversion questions. All right, let's see. Convert 0.12 kilometers to millimeters. So first question you ask yourself is, which direction am I moving in the grid, right or left? That's the direction the decimal place will move. How many spaces am I moving from the right to the left or the left to the right? And that's how many spaces you move the decimal place. What I always do when I convert is I write 0.12, and then I literally will, with my pencil or pen, move to the right or left with the decimal place, add zeros if need be. Give you guys about 15 seconds for this. Put your hand up once you have successfully converted. All right, here we go. Answer is 120,000 millimeters. So here's the way that I do it. I write down 0.12 and I move 1, 2, 3, 4, 5, 6 spaces to the right. When you run out of numbers, you have to add zeros. You have to do the exact same thing if you're moving it to the left. Excuse me. And a logic question I always ask myself after I'm done converting is, kilometers are bigger than millimeters. Okay. So my number should get bigger for millimeters. And I go from 0.12 to 120,000. My number gets bigger. Okay. So that's a quick logic question to tell me whether or not I moved the decimal in the right direction, right or left. Okay. Next one If you know how to convert in the metric system, hang tight. We'll be done with this in a couple minutes. All right, let's see. Convert 42.7894 milliliters to liters. Convert 0.000217 kilograms to milligrams. Again, don't worry about the long division questions. See if you can do these on your own. If you know how to do this and you never make mistakes, take a break. So remember, ask yourself, which direction am I moving in the grid? That's the direction that the decimal place or the decimal goes. How many spaces to the right or the left am I moving? And that'll tell you how many places to move the decimal. All right. For those people that know how to convert in the metric system, it usually only takes a couple seconds. So I'm not going to belabor the point and make this take too long. For those of you that don't know how to do it yet, you got 4 days. And again, just memorize this. Am I moving right or left in the grid? You got to have the grid, okay? And you get to use the grid on the test. Am I moving right or left? That's the direction the decimal goes. How many spaces to the right? That's how many places. How many spaces to the left? That's how many places. All right, here we go. All right, that's the long division. Okay. So milliliters to liters. I start smaller. I get bigger, so my number should get smaller. That would be 3 spaces to the left. 1, 2, 3 spaces. I run out of numbers. I add a 0, and bam. So we get our number smaller. Kilograms to milligrams. We've done this before. I'm starting with a bigger prefix, ending with a smaller one. My number should get bigger. From one end to the next is 6 spaces, and that's going to be 6 spaces to the right. 1, 2, 3, 4, 5, 6 spaces. I always throw a 0 after it so I remember where the decimal is. Okay. What? Hold on. Try this again. Sorry about that. Okay. Last metric system practice. Convert hectometers to meters, centiliters to liters. Give you guys about 20 seconds to play with these. Okay, hecto to meters, I am going to the right, and I'm going to the right 2 spaces. 1, 2 spaces. Centiliters to liters, I am going to the left, and I'm going to the left 2 spaces. 1, 2. All right, here we go. All right, so we're going right or left to right 2 spaces. I'm going to move it 1, 2, should be 0.3987. It is. Centiliters to liters, that's 2 spaces to the left. I'm here, I move it 1, 2 spaces, it should be 1.87. Logic question, going from a larger to a smaller, my number should get larger. It does by a factor of 100. I'm going from a smaller to a larger. My number should get smaller, and it should get smaller by a factor of 100, and it does. Okay, Chapter 3. You may or may not be familiar with any of the content in Chapter 3. Good news is, if you're not, you got 4 days. Here we go. Okay, Folsom Lake has a storage capacity of 5 million acre feet. The American River has a transfer rate of 500,000 acre feet per year. Calculate the average residence time for this system. I will give you the formula. Average residence time, or ART, is equal to storage capacity divided by transfer rate. ART, average residence time, is equal to storage capacity divided by transfer rate. And for those of you that can set that equation up correctly, you're like, oh my goodness, I don't even need a calculator. He made it nice by having very similar numbers. All I gotta do is cross out these zeros, and then I know what my answer is. Everybody else, grab yourself a calculator. If you don't have a calculator, you should probably have one by now, your juniors and seniors. But if you don't have a calculator or it broke and you're paranoid like me and you don't want to go to the store when you absolutely don't have to, there are online calculators. Just simply have access to an online calculator when you're taking the test. All right, put your hand up if you know what the answer is. What is the ART for Folsom Lake? By the way, these are made up numbers. I'm just using something close to home and familiar. What is 5 million divided by 500,000? And again, because I made them both fives, all you got to do is know how to cross off the zeros. All right, 5 million divided by 500,000 is, drum roll, please. I can't hear that. Never mind. All right, here we go. That's 10 years. The test question that you have to do is not going to be nice round numbers like that. You will actually have to use a calculator or do long division if you know how to do long division. But just remember, ART is equal to storage capacity divided by transfer rate. As long as you know what that formula is, bam, you're good to go. All right, next one, almost finished. Blank blank says that natural systems undisturbed by people, or left undisturbed, I believe that's, left undisturbed by people, tend towards some sort of steady state. In a blank blank, energy and or material can move in and out. In a blank system, it often changes continually over time. And I'm sorry, I said that we were talking about open and closed systems. Open and dynamic systems are the two systems that you need to know about. Yes, I know I have training today. Another song that I used to cruise in my mom's station wagon to. Oh, yeah. Falco. Okay, put your hand up if you know at least two of these answers. Wave your hand in the air if you know all three of the answers. Oh, wait, I couldn't see that you're waving. Okay, about 30 seconds. Again, chapter 3, I would focus on getting those notes that period 5 created, printed or saved somewhere. Take a look at them. The stuff that's obvious to you, I would cut that out of there. The stuff that's new to you and that is on the study guide or in the Jeopardy game, you're going to want to keep that. Okay, but there is a lot of stuff in chapter 3 that you're just not going to have to know for the test. Study guide and the Jeopardy will tell you what you will have to know about chapter 3. All right, 5, 4, 3, 2, 1. All right, here we go. Dynamic equilibrium says that natural systems left undisturbed by people tend towards some sort of steady state. In an open system, energy and or material can move in and out. That makes sense. That's kind of a logical interpretation. In a dynamic system, it often changes continually over time, and that makes sense. Dynamic means change. Okay. A last set of questions. Here we go. The environment at a global level has been changed by life throughout history, and these changes have tended to improve the chances of life to continue. This is the definition of what? It's an idea that I believe less and less in. What type of pressure is associated with rising air and rain? So what type of pressure is opposite of what happens in the Sahara? List 2 characteristics of the Missouri River. There are lots of characteristics of the Missouri River. It is a major, major drainage system in the U.S. You might open up your books to where it talks about the Missouri River and see if you can locate a couple of those. Again, if you know the answer to at least 3 of these 4 questions, throw your hand up. Sorry, during my lunch hour today, I went out and I vacuumed our pool because there's so much like ash sitting on the bottom of it. Raise your hand if you think that that was a stupid idea because it's just going to get dirty again. Because my wife told me the exact same thing. Why are you cleaning it? I'm like, because it's disgusting. Well, we're not outside because it's smoky and it's probably just going to get more ash. I thought it was a good idea to clean it because it just looked horrible. Sorry. Okay, hand up if you think you know at least 3 of these 4. All right, 15 seconds. Put your hand up if you think you know at least 1 out of the 4. I'm starting to feel somewhat inadequate. Okay, good. That's a little bit for this. Okay. All right. Yeah, I don't expect you guys to know all these questions. It's new information. Many of you haven't had an opportunity to look at it yet. All right, here we go. It's the Gaia hypothesis. And I'm having a hard time with the Gaia hypothesis now because, maybe when they were talking about changed by life throughout history, improving life to continue, maybe they weren't thinking about humans because we're doing the opposite of that. I mean, because humans are living and doing what we need to live or doing what we think we need to do to live, we're making it more difficult for life, or at least life of other species. So that's the Gaia hypothesis. Low pressure encourages rain. Okay. Remember, low pressure means that air with water vapor in it can rise. It gets colder. It loses the ability to hold that water vapor. It turns into raindrops, larger raindrops, potentially precipitation. Let's see. And the Missouri River drains 1/6. That's crazy. We have a lot of land in this country. 1/6 of the U.S. It's 2,000 miles long, which is pretty insane because, like, end to end, the U.S. is only like 3,500 miles. It's got 6 dams, and it's had major floods in 1927 and 1993. Okay, that is it for Jeopardy. Again, I've got to load this PowerPoint or load this video to my Google Drive. And as soon as that is finished, I can then upload it to YouTube. And as soon as that is done,